Hello, welcome to Chapter 7, homework questions 65 through 71. Question 65. Point M is a midpoint of AB, and B is the midpoint of AC. What are the values of X and Y? Show all work and reasoning. So let's go back and take a look. M is the midpoint of AB. So what does that tell us about AM and MB? That they are congruent. Since it's the midpoint, it bisects that line segment. And then it also says B is the midpoint of AC. So that means that this distance is the same as BC, once again because B is the midpoint. So to find x first, we can set the expression 4x minus 1 is equal to x plus 8. And then we can solve that by subtracting x, adding 1, and then dividing by 3. So x is equal to 3, and if I plug that back in, this would be 4 times 3 is 12. 12 minus 1 is 11. Plug 3 in, 3 plus 8 is 11. So they should be the same length. Now, we can set 5y plus 2 equal to the distance of both of those, and since we know that the segment itself is 11, and that entire distance would be 22, we can say 5y plus 2 is equal to 22. Subtract 2, divide by 5, and y is equal to 4. So x is equal to 3, y is equal to 4. Question 66. Read the math notes box in this lesson and then answer the following questions. So if you go to the math notes box, it talks about exponential functions along with what the initial value is and the multiplier. And this does go back to your Algebra 1 course. Part A. What is the multiplier when the cost of a large flat screen TV is decreasing 20% each year? So if you go back to the math notes, first off, remember the equation for an exponential is y equals a times b raised to the x. A represents your initial or your starting value, and b is the multiplier. And the reason why it's the multiplier, it's the number that keeps getting multiplied over and over and over and over again. The initial is where you're starting at time 0. And so as you kind of look at that, and we want to look at what the multiplier is, if you're decreasing 20% each year, you start at 100%. So 100% is where you start, but then you're decreasing 20%. So if you take 100% minus 20%, that would be 80%. Or as a decimal, 0.8. So that represents your multiplier. That's the number that we multiplied over and over. If a 50-inch flat screen TV now costs $1,200, what will it cost in 3 years? So $1,200 is going to represent that initial cost. As of right now, it costs $1,200, but in 3 years, what will it cost? Well, let's write the equation first. Y equals, so its initial cost is $1,200. The multiplier, if it's decreasing 20%, would be 0.8, and then raised to the x power. So that's the equation, and then we can plug in 3 for x. And then you can take that expression, 1,200, times 0.8, and then raise it to the third power. And when you plug that into your calculator, just plug everything in at once, and then you should get a dollar amount of $614.40. So in 3 years, we're looking at a cost of $614.40. And that's for Part B. Part C, at the same rate, what did it cost 2 years ago? And so now what it's saying, 2 years ago, if the initial was A at 1,200, but 2 years ago, then our time is going in the other direction, so that'd be a -2. So we expect our number to be larger than 1,200 because we're asking 2 years ago what it was costing. So now we can go and plug in our information, same thing we did just a second ago. We have 1,200 times 0.8, but now our x value, since we're going kind of back in time, would be -2. And so then the cost would be $1,875. Question 67. A light directed from point E is pointed at a hinge mirror with right angle as shown below. Part A. If x measures 36 degrees, find the measure of angle A, angle R, angle M, angle Y, and angle Z. let's go ahead and mark angle X is 36 degrees. We do have a right angle, so we're going to be using a couple different things. We also have parallel lines right here as well, so we can use, our corresponding angles, alternate interior, same side interior that we know. And let's go ahead and just start finding some angles, and we'll put them there at the end when we got them. So first off, if we have our parallel line cut by this transversal, all right, you can see Y and Z would be your same side interior, and they would be supplementary. We also know that the way the light hits the mirror, that angle A should be the same as angle X. So we also know angle A should be 36 degrees. Since angle A, Z, and X create a straight angle, we know angle Z is 180 minus 36 degrees minus 36 degrees, so that would be 108 degrees. We can now find the measure of angle Y. We said earlier Y and Z are supplementary because you have two parallel lines cut by a transversal, and those are same side interior. So Y would be 180 minus 108, which is equal to 72 degrees. And sorry, this one down here should have been 108 degrees. And so that gives us 72 degrees for angle Y. And then the value of M and R, for the same reason A and X should be the same. These two should be congruent. So if you take 180 minus your 72, you're going to get 108. And then you're going to divide that into two equal parts, and that would be 54. So we have the measure of angle M equal to 54 degrees, but you also have the measure of angle R equal to 54 degrees. Let's see if I've answered them all. We have A, Z, Y, R, and M. So we have answered all the angles that we were looking for, and I used the parallel lines, but we also used the idea of the light reflecting off, creating that same angle for R and M and for X and A. That was part A. Let's take a look at part B. Why must the arrows at point A and E be parallel? One possible way we could talk about the angle Y and Z being supplementary. And so since they are supplementary, then the lines A and E, or the lines that contain points A and E, would also be parallel. So you could use that as a possible way to explain that the lines are parallel. Question 68. On graph paper, graph the quadrilateral MNPQ, and then we want to decide what shape is it, and then we're going to show how we know that. All right, so there's the picture. Once again, just by looking at it, you can make some assumptions, but we want to definitely show why we know MNPQ. The quadrilateral looks to be a parallelogram. The sides do look to be parallel, but to prove that it is a parallelogram, or to show how, we need to show that line MN is going to be parallel to QP. And we also need to prove the other set, MQ, line segment MQ, would be parallel to NP. So that's what we need to show. To show that the lines are parallel, we need to show that their slopes are the same. And I could pick the 2 points and do the slope formula and everything, but I think since we have it on the graph, it might just be easier to look. And so, for example, MN, I'm just going to do my slope triangle here. It goes up 2 and to the right 5. So MN has a slope of 2/5. And then QP, once again, I can go, well, I'll do it this way, but, that's fine. I'll go up 2 and over 5 again. So each of those has a slope of 2/5, which means that the lines segments are parallel. So that's good. MQ, I'll go Q to M. So we go up 3 over 1, and then NP, I'll go from P to N, so up 3 over 1, and that has a slope of 3 over 1 as well. And you can go from any of the points, even if you start at N and go P, you're going to go down 3 to the left 1, so you'll have a -3 over a -1, which is still a +3. So either way, they both check out. So what shape, because I never really wrote that down, we think, and by showing what we did, we say it's a parallelogram. Part B. Use the function x maps to x as y maps to negative y to reflect MNPQ across the x-axis and create your new quadrilateral or parallelogram M prime, N prime, P prime, Q prime. What are the coordinates of P prime? And so this part right here, if you're confused, all this is saying is that x is going to stay the same. It's going to be mapped to itself. And then y is going to change to the opposite of y. And when you take y and make it the opposite of y, you are reflecting it, as it says, across the x-axis here. So on part B, you can see I wrote my new points. I kept all the x values the same and then just changed my y values to their opposite. So if we plot these points, -3, -6, all right, this would represent your M prime. And you can see it's just a reflection over the x-axis. 2, -8 is N prime. P is now 1, -5. P prime. And then Q prime is -4, -3. 4, -3. And so, draw on the new one. And so hopefully now you can see that reflection of the parallelogram, and it specifically asks for the coordinates of P prime. I did all 4 of them. Oops. So here's P prime, but there's the rest of them as well. Question 69. Jester started to prove the triangles below are congruent. He was only told that point E is a midpoint of the segments AC and BD. Copy and complete his flowchart below. Be sure that a reason is provided for each statement. So what was given is that E is the midpoint, or E is a midpoint of AC and BD. So that's the given, so you can see that right there. So that's good. The next thing, we have arrows going down from that. So one of the arrows says line segment AE is congruent to line segment CE. All right, and that's the definition of a midpoint. We can do the same thing because it's also the midpoint of line segment BD. So we know that BE is also congruent to DE. So we'll fill that in here. Line segment BE is congruent to line segment DE. Okay, and then underneath there, once again, we can fill in the definition of a midpoint. And then we also have over here, it's already filled out for us, but we also have over here that the angle AEB is congruent to angle CED. And that says vertical angles are congruent. So AEB would be here, and CED would be here. And we know that because, once again, of vertical angles. And so all of those come together, trying to prove that the triangles are congruent. If you go back up to the beginning, what Jester was trying to prove, we know that triangle, we'll go with AEB, is congruent, and then make sure you match up. Make sure you match up the correct points. So A matches up with point C. E matches up with point E, and then B matches up with point D. So we know that triangle AEB is congruent to triangle CED, and we know that because we have a side angle, an included angle, side, and that's one of our congruencies. Question 70. For a school fair, Donnie is going to design a spinner with red, white, and blue regions. Since he has a certain proportion of 3 types of prizes, he wants the probability of red to be 40%, the probability of white to be 10%. If the spinner, and this is part A, if the spinner only has red, white, and blue regions, then what is the probability of blue? And so since we know it has to add up to 100%, if that's the only 3 colors that we have, then we know that the probability of blue should be equal to 50%, because that's what's left. You got 40% red, 10% white, so we need 50% to be blue. Part B, find the central angles of this spinner. If it has only 3 regions, then draw a sketch of the spinner. Be sure to label the regions accurately. Alright, so get a little sketch of the spinner here. We know that half of it is blue, So that's 50%. And then from there, we know 10% is white, and then 40% is red. So we want to find the central angles. We're trying to figure out what these angles are for each of the different colors. So blue's half. So you could probably say, well, if a full circle is 360, then half's going to be 180. So we know that blue is going to be equal to 360 degrees times a half, or 0.5, would be 180 degrees. So that's kind of how we'll calculate these. On the red, we're going to take a 360 degree circle and we're going to break it up into only 40%. So we want 360 times 0.4, which would represent 144 degrees. And then the white's going to be the smallest because it's only 10%, so 360 times 0.1, and that would represent 36 degrees. Now, we should be able to add all of these up to get 360, and you can double check that, that all three do add up to 360. And so now, I think we've answered part B, so let's move on to part C. Is there a different spinner that has the same probabilities? If so, sketch another spinner that has the same probabilities. If not, explain why there is no other spinner with the same probabilities. All right, so, blue is 50%. Now, you could have 50% blue and have more than one region, but you still have to have 50% blue. So if you have a spinner and you want to still cut it up and kind of these sections of 10, 40, and 50, that's fine, but blue still has to cover 50% of the spinner. Now, could that be more than one region? Sure, you could take this and break this up into maybe 2 quarters. But still, this 25% blue and this 25% blue is still going to add up to 50%, but there's just 2 sections now. Same thing with the rest of them. You could take white and break it up into 4 different regions. Well, but they all have to still be 10%. And then the same thing for the red, 40%, but you could split it up into more than one section and say, okay, I'm going to take this and break it up into 2. We'll do 20%, 20% for red. But once again, still the same ratios that you have for the other spinner. So is there a different spinner? Sure. But once again, the regions still have to represent 50% blue, 40% red, and 10% white. You just might have more sections or, more sections to kind of land on if you break them up that way. Question 71. On graph paper, graph and shade the solutions for the inequality below. Once again, if you want to use a calculator to help you with this one's not bad. It's just a linear equation, but it is an inequality. So if you forget how to graph inequalities, you still graph the boundary line, just like you would graph the line here with a slope of negative 2/3 and an initial starting value of 0,5, which is your y-intercept. So we would just plot that, and then we could do negative 2/3. So we could go down to the right 3. You could do that a couple of times. You could also go up 2, but then you have to go to the left 3 to make sure you continue that negative slope. Now, with an inequality, you have a boundary line. So if you plugged in points, just let's say 0,5 for example, if you plug this in, this would be 5 is less than negative 2/3 times 0 plus 5. And so what you get is 5 is less than 5, which is not a true statement. So any of the points that I just plotted, or any of the points on that boundary line, will not give you a statement that is true. So we don't want to do a solid line. We fix that by just doing a dotted line. And by doing a dotted line, we just mean that that's the boundary line still, but those will not be solutions to the inequality. So where are the solutions to the inequality then? Well, they're either above the line or below the line. And so when you look at this, a couple different ways you can look at this, but one way is to just plot a point. So I'm going to take the point 0, 0. That's usually a pretty easy one to test. And we'll test the point 0, 0. And we want to know whether this is a true or false statement. So 0 is less than negative 2/3 times 0 plus 5. So that gives us 0 is less than 5. Is 0 less than 5? Yes, it is. So since 0 is less than 5, not only is this point a true statement, but any point below that line will also be. So what we do is we just shade below the line. And remember, this line goes on forever, so the shading also goes on forever. But anywhere below this line would be a solution. So you can pick any other point in this red region that I'm shading, and it would also be a true statement. And to show you that the other side is not going to work, let's pick a point on that side. Let's just go ahead and pick the point 0. Let's go 0, 9 on this one. All right, so I'm going to plug that in. So just once again, this is kind of a little extra, but to show you, if I plug that in, that would give me 9 is equal to negative 2/3 times 0 plus 5. And we're expecting to have a false statement here. Let me rewrite that. I wrote it as an equal instead of an inequality. So 9 is less than negative 2/3 times 0 plus 5, and we get 9 is less than 5. Well, 9 is not less than 5. That is a false statement. So anywhere above the line is false, so we don't shade that. You're only going to shade on one side of the line. Only one side of the line would be true. So all the solutions are all in the shading, but it's not on the boundary line because it's not, those ordered pairs will not be solutions. Now, if I put a line underneath the inequality, then I would shade the line, or I'd make the line solid, because then we would have 5 is less than or equal to 5, which would then be a true statement. So a little bit longer on that one, but I just wanted to make sure you guys were clear as to what that looks like. Once again, kind of going back to another algebra skill on this one that maybe you haven't dealt with in a little bit of time.